Hello, and this is day 2 of our x squared plus bx plus c factoring form. I'm going to go back and remind ourselves of the types of factoring we have learned, and we're going to do this periodically. The first thing you always do is you always look for a greatest common factor. That was our first day of factoring. The second thing you're going to do is you're going to see what's left after you pull out a greatest common factor, and you're going to ask yourself how many terms are there. If there are 2 terms, we look for difference of 2 squares. If there are 3 terms, we're now at this factoring pattern that we've done for the last few days where we have a trinomial, and we look to do the kind of factoring where we split the trinomial into 2 binomials. Remember, differences of 2 squares is a binomial that also splits into 2 trinomials. Just does so in the way of conjugates, plus minus, whereas trinomial factoring splits up in a way where we try to see what's going on with the multiplying and adding of different terms. So that's what we're looking at here. This worksheet is very much about x squared plus bx plus c, in other words, trinomial factoring. So what's going on with this worksheet, or the directions of this worksheet, are you basically have 10 digits to choose from. I'm going to pause and kind of write them up. These are your 10 digits. And on this page, there are also 10 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So given that, one digit goes in one blank. Every page on this is different. It resets the digits that you're going to use. So numbers 1 through 4, you're going to use all 10 digits, but only once. So there's a little bit of a puzzle in this, and a little bit of a game. I'm going to walk you through the first page, and I'm going to challenge you to do the rest on your own. This can be something that can be done really quickly once you get the way that this is going. So if number 1, we have x squared minus, and this means a number in the teens, a 1 followed by another digit. So this is either 11, 12, 13, 14, 15, 16, 17, 18, or 19. And then plus the same thing. We have another number in our teens, equals x minus something and x minus 8. So we sort of start to play this game on what can these somethings be. Well, we want to do 8 times this something here. It needs to be this number, and it needs to be a number in their teens. So this kind of actually tells us what this box is. 8 times 0 won't work. That won't give me anything in their teens. 8 times 1 would give me 8 here, but not 18. So that won't work. 8 times 2, if I make this a 2, would give me 16. So that takes care of the 2 and the 6. Now let's just check that that's our only option. If I go 8 times 3, I get 24, and that doesn't work. So it has to be 8 times 2 to give me 16. Remember, this whole number here, this is actually the number 16. It's 1 and a 6. So if you need to see it off to the side without all this crap going on, this is really x minus 2 times x minus 8, which multiplies to x squared. Let's see, minus 8 minus 2 is minus 10x plus 16, which means that this middle thing here gives me a digit of 0. So this is the only possibility for the first one, and this actually lets us mark off 0, 6, and 2 as possibilities. So now we're left with just only a few possibilities. Okay, let's move on to number 2. I have plus 1 and minus something, and it ends up being a minus 8. I'm looking at the last because that's our multiplication step, whereas this is our addition step. So since 1 times this negative box is negative 8, that means this negative box must be a negative 8. Then when I do my outer and inner for foiling, if I foil these two back together, I get x squared plus x minus 8, which means minus 7, which means that this needs to be a minus 7. Again, if you're having trouble seeing this, let's write this off to the side. X minus 8 and x plus 1, and foil that. And you get this. So that takes care of 8, and that takes care of 7. Now, if you're just watching these notes and you're just passively writing stuff down, you're not doing what you need to do to make this a successful effort. What you should be doing is anticipating pausing the video where necessary, and trying to predict what's going to happen, and then pause it again and see if you can see what happened and why. Okay, next one, we have x plus something and x minus something, and it gives us 5. Well, the only two digits that can multiply together to get 5 are 5 and 1, and 5 and 1 are both available options up the top. So we now have to decide, is it positive 1 or 5 or negative 1. If I write it like this, I'm going to end up with minus 5 and plus 1, which gives me minus 4, which is what I wanted. If I reverse those, reversing them gives me something different. It gives me plus 5 and minus 1, which doesn't work. Because plus 5 and minus 1 would give me plus 4, and this is minus 4. So this is minus 4x, and that works. That actually knocks off a few more digits up top. The 1 is gone, the 4 is gone, and the 5 is gone. This leaves 3 and 9 as my only possibilities down for this one. So 3 and 9, if I do x plus 3, 3 times 3 is 9, and check. Plus 3 gives me plus 6x, and so those are my digits. And that's the first page. Let's go to the second page, and again, I'm going to write all the digits up top. So, with all the digits written at the top, I now can see what I need to do. Now again, pause this and go ahead and finish this if you know what you're doing now. I'm going to keep working through this if you don't, but you can finish this thing right now and be done with it. X squared plus 6x plus something is equal to x plus something and plus 2. Well, now I'm looking for, the key here is that I want to get to this 6x, and so I need my outer and my inner to add up to 6x. The only way is plus 2x plus something x. It has to be plus 4x, because 4 plus 2 is 6. And then 4 times 2 is 8 when I FOIL that out. So that takes care of the 4, and that takes care of the 8. Next, if I look at what's going on with this one, I see a 7 and a 14, and that looks suspicious. And in fact, 7 times this box here needs to be equal to negative 14, which means that box should be negative 2. And then when I FOIL, I have positive 7x and minus 2x. Positive 7x minus 2x is going to give me a 5. So I have now the 5 and the 2 taken care of. So 5 goes away, 2 goes away. Number 3, I have x squared minus 10 something plus 20 something equals x minus something and x minus 3. What multiplies by 3 to give me something in the 20s? Well, 6 doesn't. 8 does, but we've already used 8, so it can't be 8. 9 does, so let's use 9. Then I have minus 9 and minus 3 to give me plus 27. And then when I FOIL that, I have x minus 3 and x minus 9, which adds up to be negative 12. So now we've got a sort of problem. Well, no, we do have a problem because we've already used the 2. So let's kind of back up for a second. This can't possibly work, so let's erase the 2. This then can't be a 9. It can't be an 8. What about a 7? If I do x minus 7, sorry for switching colors, but 7 times 3 is 21. Okay, this is going to work because now I'm using digits I haven't used before. And then if I do outer and inner, I get 10, and that makes that 0. So 0, 1, and 7 are knocked off. And that leaves behind 6, 3, and 9. Here's that 27 again, but now I can use 9 and 3. So the question is, do I want to do minus 3 plus 9, or do I want to do minus 9 plus 3? Well, I want my minus to go with the smaller one because it's a positive. So minus 3 plus 9 gives me 27. And then when I do outer and inner, that gives me 6. So that knocks off the 6, 3, and 9, and we're done with this page. Next page, I have, okay, this seems to reverse it now. Again, let me write the digits up top. I have x plus something and x minus 5, and I wanted to get to 80 something. So let's try 5 times, let's see, 5 times 12 is 60. 5 times 13, 5 times 14. If I do 5 times 14, 14 times 5, I get to 70. That's not big enough. 16 times 5 is 80, and 17 times 5, 17 times 5 is 85. So it's got to be one of those. It's either 16 times 5 or 17 times 5. If it's, we now have this middle term, 12x, so I want 5 plus, actually 5 minus something to be equal to 12. Well, that would be 17. 17 minus 5 is 12. Why do I want this? Well, if I'm looking at this from a FOIL perspective, remember my outer is going to be negative 5x, and my inner is positive something in the teens, and I want that to equal 12x, which is my middle term over here, which means that that something has to be 17x. So that's further confirmation that we have 17x, which means we've used our 7, and my last digit here is a 5 to get to the 85. Okay, erasing all these stray marks. Let's move on to the next one. We have something, let's see, now we've got 3 blanks. We want something times 7 to be in the 90s. Well, let's see what our possibilities are. If I go 14 times 7, let's just kind of sample with what that is, because I haven't used 4 yet. 14 times 7 is 28, which is 98. 14 times 7 is 98, and 13 times 7 is, let's see, 7 times 3 is 21, it's 91. So it's either 98 or 91, which means that this is either a 4 or a 3. Let's just pick one. Let's do a 4 and see what happens. If we get something in the 20s. When we do outer and we do inner, I get 7 plus 14. Let's see, outer and inner gives us 7 plus 14, that's 21. So that could be a 21, and my last could be a 98. Now, I may also have a 3 here, and if that worked, this would be 13x, which means this would be 20, and this would be 91. So we're going to keep these here kind of like a Sudoku and just keep going and see which one of the two of those it is. Okay, next one, I have 8 times something is equal to 4 times something. This something could either be a 5 or a 6. We've already used a 5 up here, so it's got to be a 6. 8 times 6 is 48. Now watch how this starts to put this all together. Since that's 48, and this is a 6, which it has to be because we already used a 5, I'm going to lock this in as an 8. Oops. Now let's do our first, outer, inner, last. 6x minus 8x gives us minus 2x. That's a 2. Now we're going to check up above. Up we have that 8, which means that this 418 is now no longer possible. This had to be a 301. We have a lot of digits we can now mark off. We can mark off the 3, the 0, the 1, the 6, and the 8, which means that 2, 4, and 9 are my only remaining digits. Okay, well, 2, 4, and 9. Oh, that's not 2, 4, and 9. Just 4 and 9. We've already used the 2 as well. So, the question is it 4 and 9 or 9 and 4? We want 76. If we do 14 times 9 or 19 times 4, we should get 76. Let's try 19 times 4. 19 times 4, if I kind of do that here really quick, 36, 1, 76. And that works. My outer is 19, my inner is 4x. We subtract to become negative 15x. So this page is done. Now, last page, I strongly encourage you to try this one on your own. But again, I'm going to write all the digits at the top. Okay, I want something in the teens times 2 to give me 30-something, but add up to 10-something. So this could be, let's see, 5 times 2 is 30. So this could be a 5, this could be a 6, this could be a 7, this could be an 8, or this could be a 9. Well, given all those possibilities, let's come back to that one. Let's check number 2. 12 times something is equal to something times 6. And it differs to become a 4x. Well, this is going to tell us what that something is. If I go outer and inner, I know something minus 12x, something times x minus 12x is equal to negative 4x, which means that I want that to be an 8x, because 8x minus 12x is equal to negative 4x. So if that becomes an 8, and 8 times 12, let's see, 8 times 12 is 96, so that would be a 96, and that works. 8 times 12 is 96, negative 12x, positive 8x is negative 4x, which means that I know 8 can't possibly be up there. Now let's kind of move on. I have, let's go to the next one, 66. That should tell you 11 and 6. So I'm going to have 11 and 6, which means that 6 is knocked off from up there. If I add them, I have outer and inner, gives me a 7, negative 17, so that knocks off the 7 from up there. And I also used a 9, so that knocked off the 9. So this has to be a 5 in the box in number 1. 5 times 2 is, or 15 times 2 is 30. 15 minus 2 is 13. With all that done, let's see what's left. I have a 5, a 0. Sorry, that's not a 10. That's a, it should be a 0. 3 knocked off. Let me just erase these. It's more fun. We have an 8 knocked off, a 9 knocked off, the 1, the 6, and the 7. So I'm left with a 2 and a 4. So I'm looking down here to see which one's a 2, which one's a 4. Well, 16 times 4 is 64, and 16 plus 4 is 20. And we're done.